Hi, today we're talking about resistance and resistivity. Now in this question, a lab experiment requires an aluminum wire of length of 29 meters and a resistance of 3.5 ohms at 20 degrees Celsius. The question asks us what diameter wire must be used. Now noting that the resistivity or P of aluminum at 20 degrees Celsius is 2.82 times 10 to the negative 8 ohm meters. So for this question, we're going to use the equation R equals P times the length times the cross-sectional area of the wire. Now we can rewrite this just to give you a little bit of intuition of what will happen. So we say P times L over A equals the resistance, and as length goes up, just looking at this algebraically, the resistance also goes up. And if the area were to go up, so if the area were to go up, we know that the resistance is going to go down. And likewise, if the length goes down, the resistance goes down, and if the area goes down, the resistance goes up. So from that, we can positively say that resistance is proportional to the conductor's length and inversely proportional to its cross-sectional area. Alright, so now that we know that, let's work our problem here. So we know that the resistance must equal 3.5 ohms. So the resistance is going to equal 3.5 ohms. And we already know that P here, alright, so P is going to be equal to this right here. So we say 2.82 times 10 to the negative 8th ohm meters, okay, multiplied by the length of 29 meters all over the area. Okay, so actually let me use a different color for the area. Okay, here we go, all over the area. Now we know that the area is equal to pi times the radius squared, and what we're looking for is the diameter. What should the diameter of this wire be? So for A, we say pi times r squared, and we get the diameter from this radius. So now we need to rewrite this problem. So we say r squared is going to equal 2.82 times 10 to the negative 8th ohm meters times 29 meters over pi times 3.5 ohms. Alright, so to get rid of, so all I did was I took this 3.5 ohms and I put it down here, and I took this r squared and I moved it up here. Alright, so to get this r squared out of it, what we're going to have to do is we're going to have to square root this problem. So we square root it, and when we do that, we can take away that square. And also, when you do this, you have an ohm here, you got an ohm here. So you're going to take that out, and because this is squared, before you did that, you'd end up with a meter squared. But since we're squaring it, a meter times a meter, you can take off one of those meters. So when you do that, you're going to get R equals 0.002727184797 meters. Now we take that radius times 2, because you got a circle, you got your radius here, and of course radius times 2 is going to give you the diameter. So times 2, and the diameter is going to give you 0.000545 meters, and to convert that to millimeters, we just move over 3 places. So 1, 2, 3. So the diameter is going to equal 0.545 millimeters. And that is how you find the diameter of this wire.